All right. Good day to everyone. Please, can you indicate if you can hear me properly? Okay. Am I being audible? Can everyone hear me, please? Okay. So you can see the board properly also. All right. So I guess we are good to go. So do we? Okay. Okay. I think everybody is all set, so we can go on. Is it clear? Is the whole thing clear? Do we have real visibility? Uh, I want to summarize what we did yesterday, and I want to try and do the solution to the assignment I gave yesterday, and we'll see where we go from there. I would love to touch binary operation, and if maybe I can touch mathematical induction, which I'm not very sure of, but we'll see. All right, so welcome everyone. You're all powerfully welcome. Yesterday I gave you something to do, and you were supposed to solve a particular question that asked you to find the domain, and you're given f of x being equals to square root of x squared plus 2x minus 15. Now, what was the answer you got? Can anybody tell me in the comment section what did you get as your answer here? This is based on the work we did yesterday. What was the domain you got? Now, because of time, I want to solve this question quickly, and you can cross-check to be sure of what you got. Now, looking at what you have right here, you were told to find, the two questions you were told to find here was, number one, to identify the domain, and then you were also told to identify the range. So these two is exactly what you're told to do, and let's see how we solve this question. Now, I told you yesterday that the range of a function is the response from the domain. And I told you that the domain is always, in a nutshell, the x values, what we call the input values. And the range will be the responses that came from x. So if you have x as 1, 2, 3, whatever was your response when you fixed in x as 1, that will be the first range, whatever you got, and whatever you got when you fixed in x as 2, and whatever you got when you fixed in x as 3. That will give you the range of your function. So looking at this work we have right here, this question we have right here, we have to find a way to get the domain. So what do we feel can be the possible values of x in this function? This is a function now. So when you look at the orientation of this function, you can see you have a square root here. And the only thing that would hinder your square root from being mathematical is if you got a negative value inside here. So values like square root of -1, square root of -3, square root of -5.3, square root of -10.1, and so on will not work in a square root. So those are the only set of values we want to avoid here, because every other thing apart from having a negative value will give you an answer that works well. So if you don't have a negative value and you fix in the square root of all these numbers, they will give you, you'll be able to arrive at something. So you need to ensure that whatever happens here, you don't have a negative answer. And the way to write that mathematically is for you to go on to say x squared plus 2x minus 15 must be greater than or equal to 0. It can be 0, but it must not be less than 0. So if you go on from here, you would be able to identify that when you decide to solve this using your factorization, you should arrive at the value of x minus 3 and x plus 5 greater than or equal to 0. Obviously, here we get our x being equals to 3 or minus 5. Now, how do you get your domain from here? If you look at this, you will notice that we can quickly do a quick examination. Of course, your x will be greater than or equals to 3. And your x should be less than or equals to minus 5. Now, let me explain to you what we're doing right here. If you have your values, let's try and fix our values for x being 3. If x was exactly 3, we would have 3 squared plus 2, 3 minus 15. This would be 9 plus 6 minus 15. 9 plus 6 is 15 minus 15. That will give me a value of 0, which works very well. 0 is still acceptable. Now, if I decide to move further to the next integer after 3, of course, you can go on. The decimals are also acceptable, but let's decide to do 4, for instance. So, which is the value greater than 3. 4 squared plus 2 into bracket 4 minus 15. Fixing 4 into this equation now, we have 16 plus 8 minus 15. 16 plus 8 will give us what? Will give us 24 minus 15. Our value here is obviously 9. Now, square root of 9 is actually possible, and it's well okay. So you can see that the values of x being 3, if you examine for 5, you will also get a positive value. So if you examine for everything greater than 3, from 3 upward, you'll be getting a value that is not less than 0, which makes this a very adequate and sufficient bandwidth for your x values. So we are okay with x being greater than or equals to 3. So let's examine this. Let's examine that of minus 5. So for you, I'm trying to do this so that you would be able to carefully bring out your result without making any mistake. So we have done for this side of things. Let's go on to do for, let's examine for these values. So you have minus 5. If you decided to move, on your number line, you remember that if you have minus 5, you have minus 6, you have minus 7, minus 8, and it decreases down the group. It decreases down. So obviously, -4 is here, -3 is here. But you see, everything here is greater. All these values here are greater than -5. All these values here are less than -5. Now, so when I say x being less than or equals to -5, I'm talking about the values that we see after, in short, towards the left-hand side. Now, let's try and examine -5 first. If you fix in -5 here, let's see what it produces. -5 squared plus 2 into -5 minus 15. This will be 25 minus 10 minus 15. This will be 25 minus 10 minus 15 is minus 25. This will give us 0. So obviously, you can see that we are dealing with -5 gives us 0. So we are very much okay with -5 being a value of x because we are not getting a negative answer. The main purpose of what we're doing is that we must not have a negative answer after we are fixing our values for x. If we're getting a negative answer, that would not be part of the domain because that would not be true. That would not be right. That will not be mathematical. You'll be getting square root of minus something. Will not, if you press that on your calculator, you'll be getting math error. So you want to avoid every value of x that produces this final result to be minus. So -5 is okay. So the exact value of -5 is okay. So now we're going to examine for -6, -7, -8. Maybe we're examining for just -6, and you can go on to examine for -7, -8. And let's see if it works well. So let's put in -6 into our equation. So we have -6 all squared into -6 minus 15. This will be 36 minus 12 minus 15. This will be 36 minus 27. So that gives us what? That gives us 9. Now, you can see that we didn't get a negative answer. So that means -6 produces an awesome result for us. So we are okay. We are okay with x being -5, -6. And if you go on to examine for -7, -8, it will also be okay. Now, but let's try and see for -4, -3. I want you to understand why our x values is less than or equals to -5. If your x values is greater than -5, let's see what will happen. Let's try and put -4. Let's try and examine for -4. This is the basics of how you're going to be able to obtain the domain and range without making any mistake. So if you pick -4 and fix it into the equation, -4 squared plus 2 into -4 minus 15. This is 16. -4 squared is 16 minus 8 minus 15. This is 16. If you do 8 plus 15, you have -23. Now, 16 minus 23, without further ado, you can see that this value here will give you -7. -7, more like you having, imagine you fixing -4 here, you're getting square root of -7, which is not going to give you a great result. So you see that -4 will not produce the right thing. So x should not be -4. So that's the reason why our band will be in between -5 downwards. Everything from -5 downwards will work, but from -5 upwards will not work. So that gives us the basis of which we're going to establish our conclusion on x being greater than or equals to greater than or equals to 3, and x being less than or equals to -5. If you're going to draw this on the number line, it's going to look like something like this. So your x value starts from here and moves down like this, starts from here and moves down like this. So these values, all the values in between here are not featured. So are not acceptable because those values will produce answers that would make your square root not solvable. So we're going to conclude using to find how, if you look at what we have right here, you can see that from -5 downwards, because from -5 downwards means it's moving from -5 towards infinity, towards minus infinity. So this bandwidth will register as minus infinity and -5. So this is one solution for your domain. All this represents your domain, but not this alone. This represents your domain. Your domain, your x values works fine for values from -5 towards infinity, which is what we wrote here. From -5 to minus infinity, your x is very much fine. You are okay with x being in that range. Now, your x also is equally fine if it was from 3 to infinity. That means from 3 upward, it's also very fine. So you can see why we conclude that our x value is this, and then we'll put a union here using our set theory, saying this union this. So we are saying this, for this answer now, your domain will be this. So if you're giving this in an examination, you have to conclude that this is your domain. That means your x values fall in this spot, and it's very much fine. It produces the right result, and it also falls in this spot also. So this and this works very fine. So that's how we get the domain for this particular question. Now, that was not the only question that was asked. We're told to find the range. We're told to find the range. Now, how do you find the range? Please pay real attention here. How do you find the range of what you have here? You have to be very, very smart. Now, your range, the first value of your range, as I explained yesterday, is always that value that is produced from your very first value of your domain. Don't forget, I told you the range is the response from the domain. So if you fix in x as 1, what comes out as that x being 1 is your range. So to find out and investigate the range of this particular function, you have to go and fix in the very first value. That will be your starting point. So we have done that already. When we fixed in x as 3, if you go on to fix x as 3 or x as -5, the very first values here, I'm sure you remember that we got our f of our equation here to be 0, which meant we had square root of 0. Don't forget, the whole range, the range is the response that f of x produced. So what was f of 3, which was the first value, or f of -5? That will give you what your first range is. What was the value f of 3? When you fixed in 3 into this place, you got 0 here. That was square root of 0. And that means that was 0. When you fixed in -5, also it was square root of 0, which was 0. This tells you already that your first value for your range will be 0. The first value for your range will be 0. Now, but you need to now go and find out what will be the last value. So looking at this, you cannot have a particular integer value as your last value, because your last value for your domain is actually termed infinity. That means it kept on moving. You didn't have like a limit. So obviously, the last value for your range, that means if you fix in infinity, let's say 10 billion now, into this your equation, 10 billion was going to produce a very high result also. 20 billion is going, so we are going to write our range as 0 to infinity. So if you ask me to give you the domain of this particular function written here, this will be the domain, what we have here, and the range will be 0, infinity. So that's the way you solve all these questions. So we have more questions that you can work with, and we have let me see if you can make your attempt on these ones. They are quite very simple. you can y equals to 1 over x minus 2. I hope you really understood this because we'll be moving to the next topic very soon. I believe if you attended yesterday's class and today's class, by now you should have a very good understanding of domain, range, and codomain. So let's just say we had a value of y equals to 1 over x minus 2. And you're told to find the domain of what you have of this function. Don't forget that I explained to you yesterday that you can have two different way they write this value. It could be written as y, it could be written as f of x. Whichever one is still the same thing. Generally, y is equals to f of x. So don't get it confused by seeing y. It's still termed as the function. Now, how do you find the domain of this? By now, I believe you should be very versatile in solving the domain of any given function. The domain is going to obviously be what are the possibilities of your x in this particular equation. Looking at this equation, for this particular function to be valid, it can carry on several things, but there is one thing it must not carry. One thing. If you try this on your calculator, if you press 1 divided by 0, if you can investigate that very quickly, 1 divided by 0 will obviously give you math error or a syntax error or something. It's going to give you an error message because it's undefined. We always say this function will be undefined. In this case, now, if you ask me to tell you where this function will be undefined, I'll tell you that this function will always be undefined if x is equals to 2. Because if x equals to 2, that means I'll be having 1 over 2 minus 2. That will be 1 over 0, which makes this function clearly undefined. So if you ask me to tell you the domain of this particular function, I would say the domain is every real value, every real number of x, every real number will work. Because if you go on to investigate, if you fix in x as any other thing apart from 2, you may not get the same values, obviously. If you can go on to investigate, it's not wrong. Put in x as 3, that'll be 3 minus 2, that'll be 1 over 1. That's something that's valid. 1 over 1 is valid. If you put in x as maybe minus 5, that'll be minus 5 minus 2, that'll be 1 over minus 7. This is valid. This is a good equation. It's okay. Minus 1 over 7 is valid. If you put in x as maybe minus 10.1 as x, minus 10.1 minus 2, if you do this, you will get minus 1 over minus 12.1. This is still valid also. So you can see that all these values, every real value, every real number fixed as hex is obviously going to make this equation very much valid, except 2. Except 2. So 2 obviously is going to be the only real number, the only number that must not be fixed into this function. So we can say, if you asked me to define a domain, I would say the domain is all real numbers except x. So the domain is all real numbers except x being 2. Now, let me try and give you a different question, and let me see how you are going to try with that. This is probably going to be one of the last questions we'll be doing on this topic, and I hope this would put a final understanding in your minds, just to ensure that you are very much clear about the difference between domain, range, and codomain. Okay, so now looking at what we have right here, let's have y equals to x divided by x squared plus 4. So now again, you are told to identify the domain. How do you find the domain of this equation? Don't forget, Domain literally just means what are the possibilities of x? What can you have x as in this particular equation? That's just a layman's way of understanding what domain is. So if you try to investigate this, you would see that this function, if you fix in any value of x that is a real number, this function will always be valid. You can fix in negative and positive. Just put any value. If you put x as -2, that'll be -2 over -2 squared plus 4. And this will be -2 over, this will be 4 plus 4. This will be -2 over 8. That's -1 over 4. This is nice. We are okay with this. This is something we are okay with. We don't mind this. But there's no value. Because of this square, you know one thing this square does? This square will always bring every minus value of x to be positive. So this means that there will not be a time when you will be able to have this x square giving you maybe -4, because if this x square could give you -4 at any point, if this x square could give you -4 at any point, then -4 plus 4 will be giving 0. Then at that point, we'll be saying x on the function will be undefined. But because of this square here, there will never be a time when any value you input as x will produce a -4. So obviously, you can't find any place where this will be undefined, where this function will be undefined. If you try to do for 0, y equals to 0 over 0 squared plus 4, that will be 0 over 4. 0 over 4 is 0. This is still valid. We are still okay with this. So that's the domain. The domain of x, the domain here in this function is all real numbers. All real numbers. There is no exception here. All real numbers. So this is where we're going to put an end to domain and codomain. Let me see a particular question here, and maybe I just give you this to do personally so that we can move on to the next topic. So I should believe at this point that there's nobody in the class that is having issue with domain, codomain. Now I will be obviously doing a more planned video on all these topics, but I believe walking into your test, you should have a very sound understanding of these topics. Now imagine you have f of x being equals to x plus 1 over x squared plus 2. Now, if you're told to find x minus 1 rather, if you're told to find, number 1, you're told to find f of 0, then you're told to find b, f of -1, then you're told to find c, f of 2a, then you're told to find d, f of x plus h. Now, just to ensure you have a robust understanding of what we're doing right here, what you're seeing is something I believe everybody should have a very good idea of what they are supposed to do, because what you're going to do here is basically just substitution. So when you have a question like this and you're told to find f of 0, the meaning of this is obviously it's like you had f of x. So when you're told to find f of 0, it's basically them telling you that your x here was 0. So all you have to do is to fix in 0 as your x into your function. So to find f of 0, that will be f of 0 will be equals to 0 minus 1 over 0 squared plus 2. That will be minus 1 over 2 as our answer. So that's so simple. You can find f of minus 1 yourself. Tell me, can you quickly tell me what your answers are in the comment section? Tell me what f of minus 1 is. And while you're doing that, let me try and solve for f of 2a. F of 2a obviously will be 2a. You fix in, of course, if f of x, you add f of x, and you are told to find f of 2a. That means wherever you saw x, you're supposed to fix in 2a. So in this case, you have 2a minus 1 over x squared plus, not x squared anymore, 2a squared plus 2. This will be 2a minus 1 over 4a squared plus 2. So that's how you go on to solve questions of this sort. So you can go on to find for f of x plus h. All you have to do is, in that case, you'll be fixing x as x plus h. So wherever you saw x, you'll be replacing with x plus h. So that's all about we'll be doing on calculus tonight. Let's run very quickly into binary operations, so that we can see. I will just be solving questions on that and giving you the right understanding of what you need to know on binary operation. And then later on, we'll be doing a much defined video for that topic. And then we'll be able to explain much more deeper. All right. So we have binary operation. Okay. Some of you got minus 2 over 3. That's actually very correct. So binary operation. Please, I'll be giving you a classwork while we're studying binary operation. So please stay very attentive so that you'll be able to solve every question I'll be giving. So binary operation we'll be studying just 4 different aspects of binary operation based on what I can see. So we'll be talking about commutative. We'll be talking about associative. We'll be talking about identity. We'll be talking about inverse. So without wasting time, let's get straight into commutative property. So as I said already, I would not want to spend so much time explaining because I want to focus more on preparing you for your test ahead. Now, when you're dealing with commutative properties under binary operation, I want you to understand that the concept of commutativity is very simple. If you have a binary operation defined on star, that's the way it always comes. The binary operation is defined on star, and you have a star b given as, let me say for instance, is given as a square plus b square. Let's use this for instance. Now, if you have a binary operation given as what you have right here, if you are told to investigate if this binary operation, what you have right here, is commutative, all they're asking you to do is to tell them that does a star b, will it mean b star a? And don't forget, I just talked about substitution. If you are dealing with binary operation, you need to learn how to substitute properly. So right here, look at what you have here. Don't get it confused, just stay with me. You have a star A times B or A star B, A binary operation B, whatever we want to call it. I will explain more on that later. It's given as A squared plus B squared. So if I'm going to say this binary operation has commutative property, that means when I decide not to do A star B and I decide to do B star A, I must have the same thing as A star B. If I don't have the same thing, then that means it's not commutative. So the whole idea is for you to investigate if this is commutative, what you have right here is commutative or not. What you have to do is to try and find B star A. You already have A star B given as this. So let's find B star A. How do you find B star A? All you have to do is, wherever you saw, this is B as the first now, and A as the second. So in this place now, A was the first, B was the second. The first star the second was the first square plus the second square. Now in this case now, B is the first. So obviously, your answer to B star A will be B square plus A square. Now if you look at this, you can see clearly that A star B, which is what you have here, is the same thing as B star A. So we can conclude that it is commutative. Now, let me give another function. And I want you to investigate if this is commutative or not. So imagine you have A star B given as A square minus B square. A square minus B square. So what do you tell me? Is this commutative or not? Is this commutative or not? All right. If you look through on what we have right here, I want you to investigate it first, and then let me wait for you for 1 minute, and then I will solve it. Is this commutative? This function, this binary operation, is it commutative or not? All right. I told you you have to go, if it's commutative, then A star B must be B star A. You already have A star B. Let's try and investigate for B star A. B star A, that means the first now is B, will be B square minus A square. You can see that. So my question to you is A star B the same thing as B star A? Obviously not, because A square minus B square is not the same thing as B square minus A square. If you try to arrange this well, this will be minus A square plus B square, which obviously is not the same thing as what you had initially. So obviously, this is not commutative. So that is how you just have to understand commutativity under binary operation. Now, let's try and solve a few questions. We're given this question, A star B being equals to 1 over 2 A plus B. I have a question I would love you to solve very soon, so please pay attention. So I want you to investigate if this is commutative and if it's associative. Okay, I think you should first investigate commutativity, then we'll go on to explain the associative property under binary operation. Now, for you to find if this is commutative or not, all you have to do again is to investigate for commutativity. A star B must be equals to B star A. So obviously, B star A here will be 1 over 2. B comes first out, that will be B plus A. If you look through on this, you will see that B plus A and A plus B is the same thing. So A star B here is equals to B star A. So we conclude that it is commutative. So I would love that you follow through on every solution we are solving, and you can walk ahead of me so that you will be able to understand the topic very well. I'll be giving a particular work very soon, and I would love everyone to get it. So let's leave commutativity and let's go on to associative property under binary operation. Now, for associative property, what you have to deal with is different a bit from this. A star B star C must be equals to, for associative property, must be equals to A star B. Now, look at what I have right here. You may not understand until you start to solve. A star B star C. You can see right here that A star B is in a bracket here, and here B star C is in a bracket here. For you to decide that something is associative, then what you have here must be equals to what you have here. So let's try and investigate for this particular question we had. How are we going to solve? Or let me just try and solve, or let's use this rather. Let's just use what we have right here, and I hope you can understand it. Now we have A star B was given as 1/2 A plus B. Now I want you to understand that this, what you have right here, just meant, if you want to understand it better, just say it this way. All this A and all this B, they are subject to change. You don't have to be read on the alphabet, but understand it this way. This will help your understanding. Always say the first star the second. So in this case, you understand that A could be another letter in a new question, B could be another letter. So you are not too rigid on A and B being used. So if you look at this and you try to investigate this, you are told to find if it's associative or not. So what you have to do is that you have to use this. This is the property that must be fulfilled for you to say something is associative. So how do you fulfill this property? Now, can you go on to try and find, you have known A star B. This is A star B. That means when you had a first with a second, this is it. And luckily enough, it was the same alphabet. So A star B is this. So to investigate this left-hand side, we can write it as this. 1/2 A plus B. This is A star B. What we have here, this is it. This is it. Then we can have star C. Because we want to resolve this whole left-hand side. So A star B, we have brought it as this, then star C. Now, stay with me and try and understand what's going on here. We are done with this, the within of this left-hand side. We have not come here at all. We are still here. We are done with the within. So now that we now have this within, this becomes like the first. This whole thing becomes like the first. It's more like you were writing, imagine you wanted to write it as P star Q. It's more like this was now P and this is now Q. So all I want to say now is that this becomes first, this becomes second. So for you to solve this new thing you've gotten, you will be putting all this thing as like the A. I told you to always see this as first and second. Don't forget, this is the basic operation that the binary operation had. A star B, that means first star second, is equals to 1/2 into bracket first plus second. So whatever you have, whatever was the first and whatever was the second, you will arrange it in this way. You will say 1/2 the first plus the second. If you can follow me that way. Now, we are done with A. We wanted to resolve this. A star B, okay, we saw that A star B, we used A star B, we got this, we fixed this inside here. Now, this is now a new thing entirely, in which this whole thing is the first and this whole thing is the second. So now, if we want to resolve this, what we have to do is to go on to put this as the first, this whole thing as the first, and this as the second.
Of course, this is the binary operation on which it is defined. So this thing star C will be equals to 1 over 2. I'm using this equation 1 over 2 now into bracket. Don't forget first plus second. This is the first now. 1 over 2 into A plus B plus the second. This is first plus the second. What was the second? The second was C. So if you can look through on it very well, you would see that we are just using, this is the binary operation. This is the standard you are going to use every moment in this question. When you have a first and a second, for this question, it will plus second. So when you fix in A star B as this, which was the initial, you put in A as first and second, you got this, you fix this here. So this star C, you would have 1 over 2 first plus second. Now, you can go on to resolve this, because for you to decide that if this is associative or not, your left-hand side, what you have here, your left-hand side, this property right here, must be equal to the right-hand side. If that is not the case, then it is not associative, even if the difference is just a minor sign. So it must be exactly the same thing. Now, looking at what you have there, you can resolve that. Let's just fix this somewhere. Let's fix that somewhere, and let's try and solve for the right-hand side. So if we decide to solve for the right-hand side, now looking at this, of course, you know in mathematics you solve the bracket first. So when we want to solve, this is the left-hand side. Let me identify this as left-hand side. This is it here. So let's try and solve for the right-hand side. This is the right-hand side. The right-hand side said A star B star C must be fulfilled. So let's try and find this. You have to resolve this first, B star C. What is B star C? It's like putting B here and C here. So B is the first, C is the second. So obviously you'll be having A star. What will be B star C? B star C will be 1 over 2. You're putting B now and C into B plus C. So this is the first step. So it's like we are trying to solve. It's just substitution. The basic of all these properties is knowing how to substitute properly. So I really hope you are able to stay with me. We're trying to solve for the right hand side. B star C. B star C. We resolved it using the general binary operation. This was giving us a pretext, giving us at the beginning of the question that it is defined on A star B being 1 over 2 A plus B. So what you wanted to do for B star C, obviously you just substitute B as A and C as B, and you have what you have right here. Now a new change has happened. Now you have this star this. So this is now the new first. This is now the first thing now, and this is the second thing. So trying to solve this, you have to use the same binary operation. To use the same binary operation, what you have to do, you put in 1 over 2. This is the first. A now is the first. Of course, it's still the first here. So you have your A, then plus A plus. Now, this is your second. So your B will be 1 over 2 into B plus C. So this is how you solve the right-hand side. So this is what you have now. So we have our left-hand side giving us what we have here, and our right-hand side giving us what we have here. So now you need to go on to investigate. You can go on to do your LCM if you want to. Try and find the LCM of what you have there. And I'm almost very sure. I'm very sure you would realize that the two are not associative. So what you can do is to just find the LCM of what you have here. If you decide to find the LCM here, you would obviously get, let's try and resolve this. 1 over 2 let me see if I can resolve it here. The LCM here will be 2. This will be A plus B plus, and this will be 2C. So if you have 1 over 2 into this, so this will obviously be 1 over 4 into bracket A plus B plus 2C. This is just LCM and the understanding of LCM. So let's try and solve for this one. Of course, you find the LCM as 2. Then you'll be having 2A plus B plus C. That will be 1 over 2 into this. So this will be 1 over 4 into 2A plus B plus C. Now investigate both of them. This is left hand side. This is right hand side. Are they the same thing? Absolutely not. You can see you have A plus B plus 2C. Here you have 2A plus B plus C. So because of that, we conclude that it is not associative. That's just the understanding of what we're dealing with. So because of time, I want to run straight to inverse and identity, because I want to see how we can touch everything. We may not be able to solve all the questions possible. When we have a much more detailed video, then we'll solve much more questions. I really hope you guys are following, and I'm sure you are understanding. Let's see out. Let me look for a question for identity element. So how do you solve for identity element? Now, I see a question here, a very interesting one. Let's try and solve it. Identity element. You're still under binary operation, solving for identity element. So we'll be running on very soon. I want to give you a particular classwork to do, and I would love to get your responses in the comment section. So look at this question right here. You were told that the binary operation star is defined on this. For obviously for A, B being an element of Q and Q being a set of natural numbers. The question was then asked, what is the identity element? Now, I want you to understand that this identity element we're talking about here is very similar to that of matrix. Remember when we were doing matrix, we said A times identity element equals to identity element times A and is equals to A. So I explained to you that identity element is more like just like a mirror. It produces the same matrix. So anything times identity element will be the same thing. Now, you're told to identify the identity element for this particular operation. So for you to have an identity element in this operation, this must let's call, according to how you have been following, let's call the identity element E. Let's call it the alphabet E. So we have this binary operation A star B being 2A B. If something is an identity element based on what we have here, I want you to know that A, when you pick any of the whatever you have here, A star identity element, as I told you here, must be equals to identity element star A, and it must be equals to A, just as I said here, just similar to what you have in matrix. So we can go on to just pick one of these ones, any of them. We can say, obviously, this is how sometimes we write that A times identity matrix equals to A. So A times E equals to A. So if A star E equals to A. Now don't forget, I've explained to you the use of how you use what you were given, the binary operation on which the function on which it was defined on. So in this case now, you're having A star E. So when you use, you have to use the initial equation you were given. And using the initial equation, you'll be having A star E will be equals to, of course, this is first, this is second. This will be 2AE, because you had first and second, 2 times first times second. So here your first was A and your second was E. So this is what your A star E will be equals to. So we can say 2AE is equals to A. Don't forget we are trying to find the identity element E. So in this case now you can see that your E will be equals to A over 2A, which will give you obviously the value of 1 over 2. Because A will cancel A, you'll be left with 1 over 2. So your identity element E is 1 over 2. So the basic idea is to never forget this, that A times identity anything is always identity times that thing. It applies also under binary operation. So we had this is the general rule, and then we're able to bring just one of it just for the sake of being able to calculate. And then A star E, we went on to use the initial function we had, and then we went on to produce our identity element as 1 over 2. All right, I want to give you the question I want to give you quickly. We can always pick back on some of these things in some later classes. So this is the question I have for you, and I want you to just produce your results in the comment section. I want everyone to participate, so please be. So we have this question. Okay, let me try and get this off. Can you indicate if you are following me? Can you indicate in the comment section if you are able to follow me? Can I get your comments, your responses, if you are able to follow through on what I've been explaining? So you can start solving these questions. I would love to get your answer in the comment section. Just start to solve quickly. So I want to see your knowledge, all the knowledge you have on binary operation. So who has gotten any values? Who has gotten any value? I think somebody has gotten R to be 2. That's the very first one. Okay, 2 people has gotten R being 2. Okay, I can see some other people getting R as 2. Okay, then you can go on to the next one. And the next one, can you get the value for K? What is K? If you're wondering how they got R as 2, let me try and solve right here. Of course, if you say R times 2 is 1, so all you're telling us there is that the first star, the second, of course, don't forget you have this initial one. So you have R star 2 to be equals to R plus 2 over 2r. That's, or let me just write it as r times 2 in case you need to know that. The first plus the second, which was r and 2, then how, so you'll be having r plus 2 over 2r equals to 1. So r plus 2 equals to 2r, cross multiplying obviously. Then 2r minus r equals to 2. Then r equals to 2. That's how you are solving that. Okay, k is what? All right. You got k as 6. Okay, that's correct. That's correct. I love that. I love that. K is 6. All right. I love that. I love that. Those of you following, I love that. All right. So we can go on to investigate for the next one. We're about to end this class now. I want to leave you with the right understanding. So what did you get as Q? Q. Okay, I think somebody has gotten -7. Okay, somebody got 7. Are you sure it's 7? Are you sure S is 3 or -3? Okay, somebody has gotten S as -3. That's correct. I love that. Q is not 7. So in case you're wondering, this is the values. We have K giving us 6. We have Q giving us -7. We have S giving us -3. So follow the procedure and make sure you are very accurate while calculating. You cannot get it wrong. So guys, this is where we'll be stopping at this time. I guess we've had a great time. This is the very first live class on YouTube, and I'm really glad you guys joined. I'm glad you really paid attention. We would have much more detailed video available on the channel very soon, and we'll go on from there. So guys, I wish you all the best in your test this week, and I hope you prepare very hard. You can't go wrong if you prepare well. So thank you guys for joining. At this point, we'll be ending this virtual class. So we'll be meeting very soon. All right, guys. Take care of yourself. Take care of yourself. Take care of yourself. All right. Bye-bye, everyone.